بسم الله الرحمن الرحيم. ان شاء الله دلوقتي هبدا السكشن 1. بيتكلم عن حاجه اسمها planetary motion and gravitation. المفروض ان احنا خلصنا السكشن 1 وسكشن 2 في السكول، وعلى الاساس ده انا ببدا يعني احاول اعمل سامري ونحل questions عليه مع بعض. planetary motion can describe the motion of planets خلاص around planets عموما around the earth by three laws. كبلر فيرست لو اند سكند لو اند ثيرد لو، وفي الاخر بندرس حاجه اسمها جرافيتيشنال فورس واللو اوف يونيفرسال جرافيتيشن. كبلر فيرست لو كان بيتكلم على state that the particles of the planet are ellipses with the sun at one focus. يعني هو بيتكلم ان فكره الاربيتال of the sun around the orbital of the planet around the sun, not a circular orbital, it's an oval shape. Take the oval shape or ellipse shape. الellipse shape that has two centers. The oval shape that has two centers as it's an intersection between two circles. فيبقى عندي two centers. The sun exists في one center of them. الsun موجودة في center منها. يبقى الموضوع في الفيرست رول سهل جدا، مفيش أي حاجة. هو عبارة عن state 2 points. In the first point in the planets revolve around the Earth in ellipse shape. The sun exists at one center of the two centers of this ellipse shape. The second law بيقول لي the sun exists in one center خلاص. So it has different radius according to the position of Earth. I'm going to talk about the Earth or even any planet. Let's say the Earth. The Earth exists in different positions. So it has different radius according to the position and according to the distance between the sun and the Earth. فبيقول لي ايه دلوقتي؟ لازم افهمين حاجه ان الموشن of the planet around the sun ده the speed of the planet itself change from one point to another due to the change in the gravitational force. يعني logically if the planet exists in position number one here, the speed of the planet itself going to differ from the position as ايه بقى؟ as the difference between the planet position and the sun differ according to the difference between the distance between them. يعني ايه according to the difference between the distance between them؟ logically كده the distance between the planet والsun هنا are near to each other. يبقى simply gravitational force between them is greater. يعني لو قلت هنا انا عندي force of gravity هنسميها force of gravity 1 اكبر greater than the force of gravity 2 اللي هي represented by the distance between the second position ده والsun itself. يبقى احنا عارفين نكتب على جنب كده نوت ان كل ما الديستنس increase اللي هي represented by the radius of the motion خلاص increase the force of gravity going to decrease. طيب مين عنده هنا velocity اعلى؟ البلانيت at this point at this position ولا البلانيت على البوزيشن نمبر 2؟ طبعا انا كل ما اقرب فالجرافيتيشنال فورس بتزيد، فلما الجرافيتيشنال فورس بتزيد يبقى البلانيت ده محتاج ان هو يسكيب the gravitational force. طب how to escape the gravitational force? The escaping from gravitational force by increasing the velocity of the rotation. انا عايز اهرب، فالحل الوحيد ان انا ازود السبيد اوف روتيشن. فهقول as the force of gravity increase the speed of rotation also increase. Sorry, make it v. خلاص I'm going to make it v. Sorry. v will increase. يبقى كده ريليشن ما بين الفورس اوف جرافيتي والفيلوسيتي دي دايركت ريليشن، لكن الفورس ما بين الراديوس والفورس اوف جرافيتي دي انفرس ريليشن. طب تعال نشوف كده ببساطه. لو انا عايز اتكلم واقول كل ما الراديوس يزيد الفيلوسيتي هيحصل لها ايه؟ يبقى كل ما المستر راديوس يزيد الفيلوسيتي هتقل. خلاص، يبقى دي اسمها inverse relation. R is inversely proportional with the velocity of the planet او planet's velocity. فبقى كيبلر بيقول لي ايه بقى؟ خد بالك انت عندك الفيلوسيتي will change والR اللي هي distance will change. طيب يبقى هنقول at equal intervals of time. This point is very important. At equal intervals of time. At equal intervals of time خلاص an imaginary line from the sun to a planet, from the sun to the planet, sweeps out, cover out equal areas in equal intervals. يبقى خد بالك انا لما يكون عندي equal time equal time interval، شايفين الاريا دي اللي هي البلانت draw it from the position of x to position of y، الاريا دي. This area is also equal to this area. Let's choose another one. This one. This area. Triangle ده. ليه بقى؟ الاريا دي equal to area دي عشان الديستنس دي greater من الديستنس دي. فلو هروح احسب area of triangle هلاقي ان التو areas دول equal to each other. اتفقنا؟ بس في شرط اساسي عندي، في important condition. ايه هو الامبورتنت condition؟ ان انا عندي equal intervals of time، عندي equal intervals of time. ده كده كيبلر سكند. اوكي؟ طيب كيبلر ثيرد لو بقى بيقول ايه؟ بيمنشن وات؟ Kepler's third law. Kepler's third law represents the relation between the average atomic radius of certain planet and the average atomic radius of another one. احنا اتفقنا لو الباث بتاعي I'm going to consider the path itself circular path. ليه؟ لأن أنا هتعامل مع حاجة اسمها R average. أنا مش هتعامل هنا مع أولاد مع radius of ellipse، لا، أنا هتعامل مع average radius، هتعامل مع حاجة اسمها average radius. طب تعاملي مع الافريج radius ده هيخلي كأني بتعامل مع value constant اسمها R، والconstant value دي كأنها drawing a circle. طيب هو مش circular path، هو أنا هتعامل مع R average certain value for a certain planet. As the position of the planet from the sun increase، يعني كده نشوف، يعني تعالى كده، يعني انا دلوقتي هقول R increase. طيب كل ما R increase الفورس اوف جرافيتي هتزيد ولا هتقل؟ هتقل. طب كل ما الفورس اوف جرافيتي هتقل الفيلوسيتي محتاجه انها تزيد تو سكيب ذا جرافيتيشنال فورس ولا هتقل؟ هتقل. طيب لما الفورس قل يبقى التايم الفيلوسيتي تقل، يبقى التايم بتاعي او تايم نيدد او required to make one complete revolution هيزيد ولا هيقل؟ لا، التايم هيقل. طب اساسا التايم اوف ان كومبليت ريفولوشن ده انا بسميه periodic time. So by increasing the average radius the force of gravity between or gravitational force between a planet and sun decrease, and also the revolution velocity of the sun of the planet decrease, and also the periodic time decrease. Kepler found a relation between the periodic time itself and R, which represents the average radius. بيقول لي the square of the ratio of the period of any two planets revolving about the sun around the sun is equal to the cube of the ratio of their average distance from the sun. طيب واحد كده، واحده واحده. هو الريليشن ما بين الار والتايم direct relation ولا inverse relation؟ انا اسف، هو هنا التايم increase لان it's going to take longer time مش decrease. time going to increase ماشي معلش. time going to increase لان it's going to take a longer time to cover the path or the orbital path. حلو قوي. طيب as the time of the radius increase, the time going to increase because the circumference itself of the circle going to increase. So r I'm going to write here r average increase, or we can write it by another way. We can write it like that. ما تلخبطش. هكتب هنا r average EV average. خلاص. As r average increase, the value of periodic time also increase. Periodic time also increase. So the relation between r and time is direct relation. To remove the relation sign, we have to put equal, and this equal must has a constant here. يبقى r equal constant multiplied by t. To find the equal or to find the constant value, we have to find the ratio between two planets. يبقى by finding the ratio to planets, we're going to find the final law of Kepler. TA over TB squared equal RA over RB cubed. Hence, this rule represents a relation between the periodic time or the time needed to complete one rotation around, or one revolution around the sun, and the radius of the circular path, or the average radius between the sun and the planet itself. For example, you can the universal law of gravitation. Universal law of gravitation represents the gravitational force which exists between two objects. They have masses m1 and m2. يبقى انا عندي هنا mass m1 وعندي mass m2. For any two objects, the gravitational force attracts them to each other as long as these objects have a certain mass. Having the mass makes them own a gravitational force. Right. As the masses of the object increase, the gravitational force itself is going to increase. As the gravitational force itself depends on the masses. So gravitational force is directly proportional to the mass of the first object, the product of the mass of the first object multiplied by the mass of the second object. Right. We said before, as the distance between objects increase, the gravitational force decreases. Here we applying the ratio with constant masses. So we can say that as the gravitational force increase by decreasing the radius, or as a result of increasing the radius, the distance between two objects, the gravitational force will decrease. It's an inverse relation, but the inverse relation with r squared not r. الريليشن هنا يا ولاد مش مع r بس r squared. طيب يعني ايه المشكله ان هو يكون مع r squared not the r itself؟ ده معناه ان small change in r going to make a big change in force of gravity. يعني لو غيرت الار بتاعتي الافريج ريديوس ده او الديستنس بين تو اوبجكت وات ايفر بقى هنسميها حسب انا ماشي ازاي. لو هما تو اوبجكت exist in linear system يبقى عندي distance between them. If they are exist in a circular path يبقى انا بتكلم على الافريج ريديوس بتاع السيركلر باث بتاعي. معنى كده ان اي تشينج صغير قوي في الديستنس ده going to affect the gravity by huge value because the FG is inversely proportional to the square of the radius itself. To find the rule by the end, I need a y Just a minute. A white area. Let's say that Fg is the force of gravity directly proportional with m1. Fg is the force of gravity also directly proportional to the mass of the second object. Fg is the force of gravity inversely proportional to r squared. So we can say that Fg is proportional to m1 multiplied by m2 divided by r squared. To remove the sign of relation and put equal, we have to put a constant. So the constant here is g. If Fg equal g multiplied by m1 times m2 divided by r squared. G is a constant, universal constant of gravitation, and it's equal to 6.67 times 10 of power negative 11 meter squared, kilogram minus 2, second minus 2. So this figure represents the universal gravitational constant, universal gravitational law Fg خلاص, which is represented by the mass of two objects divided by the square distance between them. مين العدسه اللي بره دي؟ Finally, to find the time or the periodic time of the rotation itself, the time is equal to 2 pi square root of r cubed over gms. Ms here is the central mass. Sun is represented at the center. So I'm going to insert the mass of the sun inside the time. If I'm going to replace the solar system by a satellite revolving around the Earth, so the time will be 2 pi square root r cubed divided by g, the gravitational constant, multiplied by me. In this case, the mass at the center, or the central mass represented by the Earth. يبقى دايما الماس عندي اللي في الرول هي الماس which represent the central mass. Is the central mass. Is the central what? Is the central mass. طيب. كده احنا خلصنا الفيرست lesson or first section. And I'm going to post it. Then I'm going to post and make the second section, inshallah. Be ready for the second section.